In this video, we will explore the ideas of limiting an excess reactants using the familiar reaction between baking soda and vinegar. Notice the effervescence, which indicates one of the products of this reaction is a gas. Vinegar is a dilute solution of acetic acid, and baking soda is pure sodium bicarbonate. This is an acid-base reaction. The proton from the acetic acid is donated to the bicarbonate ion, forming carbonic acid. However, the carbonic acid is unstable. It rapidly decomposes into carbon dioxide and water. The other product of this reaction is sodium acetate. Each of these flasks contains 70 milliliters of vinegar. Each balloon contains baking soda. The first balloon contains 2 grams, the second 4 grams, the third 6 grams, the fourth 8 grams, and the last 10 grams. What do you predict will happen when the balloon is raised and the two reactants mix? This is the first flask, which contains 2 grams of baking soda. What do you predict will happen now with twice as much baking soda? What will happen to the volume of the balloons as we steadily increase the amount of baking soda added to equal amounts of vinegar? Did your prediction match the results of this experiment? Let's take a closer look at the contents of each flask. Note that flasks 3, 4, and 5 contain unreacted baking soda. Why do you suppose the baking soda has not reacted? This is bromethymol blue, an acid-base indicator. When added to vinegar, it is yellow. When added to a water solution of baking soda, it is blue. Now let's add the bromethymol blue to each of the flasks. What do these colors suggest about the contents of each flask? The concentration of acetic acid in vinegar is 0.96 molar, or in other words, 0.96 moles of acetic acid are present in every 1 liter of vinegar. Each flask contains 70 milliliters, or 0.07 liters of vinegar. Therefore, each flask contains 0.067 moles of acetic acid. 2 grams of sodium bicarbonate were reacted with the acetic acid in the first flask. This is equivalent to 0.024 moles. In flask 1, before any reaction took place, there were 0.067 moles of acetic acid and 0.024 moles of sodium bicarbonate. According to the balanced equation, acetic acid and sodium bicarbonate react in a 1-to-1 ratio. Therefore, 0.024 moles of sodium bicarbonate will react with 0.024 moles of acetic acid, forming 0.024 moles each of carbon dioxide, water, and sodium acetate. As this chart shows, when the reaction has reached completion, 0.043 moles of acetic acid still remain in the flask because the sodium bicarbonate has been completely consumed. According to our calculations, there should be some acetic acid left in flask 1. That means if we add more baking soda, we should see a reaction. Perform similar calculations for the 4 remaining flasks, in which 4, 6, 8, and 10 grams of baking soda were added to 70 milliliters of vinegar. Examine the results of your calculations and compare them to the observations made in this demonstration. Explain why the balloons initially increase in volume, but then remain constant. Explain why solid remains in flasks 3, 4, and 5, but not in flasks 1 and 2. Explain why the bromothiamyl blue is no longer yellow in flasks 3, 4, and 5. Chemists use the terms excess and limiting reactants. How are these terms defined? For each of the 5 flasks, what is the limiting reactant? What is the excess reactant? Finally, what is the mass of sodium bicarbonate needed to completely react all of the acetic acid in the 70 milliliter sample of vinegar so that neither reactant is in excess? This is what chemists call the stoichiometric amount.